Why does a sharp wave of bitterness instantly cause a subconscious recoil? In the grand design of human survival, bitter is our most advanced toxicological alarm system. While we possess only a few receptors for sweetness, our tongues are equipped with 25 distinct bitter taste receptors, known as the T2R family. This disproportionate sensitivity is a survival mechanism encoded into our DNA, designed to detect microscopic traces of lethal alkaloids and plant toxins before they reach our stomach. But in the modern kitchen, this ancient warning system is transformed into the ultimate tool for culinary complexity. Bitter is the architect of depth. On its own, bitterness is jarring, but structurally, it functions as a contrast engine. Think of it as a flavor anchor. In a perfectly balanced espresso, a dark chocolate ganache, or a charred Brussels sprout, bitterness cuts through heavy sugars and intense fats, preventing a dish from becoming one-dimensional. It provides the negative space that allows other tastes to truly shine. When we manipulate bitter ingredients, we are engaging in a delicate game of molecular masking. Bitterness is highly water-soluble, meaning cooking methods like blanching can draw out excess bitter compounds from greens. But the ultimate chef's trick lies in cross-taste suppression. Salt is a powerful cognitive jammer for bitterness. Sodium ions physically interfere with our T2R receptors, blocking the bitter signal from reaching the brain and simultaneously unmasking hidden sweetness. Acidity, as we discovered in Chapter 4, works similarly, using low pH to chemically alter and soften harsh, bitter edges. Beyond taste balancing, bitterness is a masterclass in organic chemistry. Consider polyphenols in extra virgin olive oil, tannins in red wine, or caffeine in coffee. These compounds don't just register on our taste buds, they interact with saliva proteins to create a tactile sensation, astringency. Managing bitterness is not about eliminating it, it is about calibrating these volatile compounds to achieve structural symmetry in your dish. Pro tip: if you are grilling or searing vegetables, that dark, carbonized crust isn't just burnt food, it is controlled pyrolytic bitterness. By carefully balancing this char with a touch of sea salt or a splash of citrus, you bypass the evolutionary alarm and unlock a sophisticated flavor profile that signals maturity to the palate. In this final chapter of our 5 Tastes series, we've unraveled bitter, no longer a signal of danger, but the definitive marker of culinary maturity and structural depth. This is science of cooking. Here, we don't just cook, we prove that the kitchen is actually the most delicious laboratory of applied physics and chemistry. This concludes our journey through the 5 tastes. Our class is officially dismissed. If you enjoyed discovering the hidden mechanics behind how we perceive flavor, make sure to hit that like button, subscribe, and check out the full playlist. Keep experimenting, keep analyzing, and above all, stay with science.